Hello, and welcome to the first chemistry video of this cell educational series. Today we're going to be covering how to balance chemical reactions. There might be a few other things you should know, and we will post videos on those soon, such as how to read a periodic table and how to predict chemical reactions to begin with. Both of those are relatively advanced concepts, and this is something you can understand without really knowing either of those, but it's useful to know anyways. So let's go ahead and get started. Let's begin with the formation of water. It's a relatively simple chemical reaction, and it comes from the formation of hydrogen gas and oxygen gas, which react to give water, which is H2O. So let's go ahead and look at this right here. So on the left-hand side, we have two hydrogen molecules. When the number is in the lower right-hand side of your element, it's saying that you have two of these bonded to each other. And the same thing goes here. It says O2, so we have two of these bonded to each other. This number will never change. So when you're predicting chemical reactions, which will be covered in a future video, you should never try and change this number on this side. Okay, with that out of the way, let's go ahead and start counting. So here we have two hydrogens and two oxygens. So let's go ahead and write that down. H and O for hydrogen and oxygen. We have two of each. Now on the right hand side we have two hydrogen and there's no number here. So in chemistry, whenever it's a 1, we generally omit it and leave it out. That's why there's no number here. So what this is saying is that there's one oxygen. So here we have two hydrogen and one oxygen. So if we look at the left-hand side, since we have two oxygen, but on the right-hand side we only have one, we can say that this is not a balanced chemical reaction. So what we're going to have to do is we're going to have to find a way to get another oxygen on this right side. Since the water molecule, H2O, has one oxygen, and we need two, we're going to need at least two water molecules. So let's write a 2 here. So now it's 2H2O. So we have 2H2, meaning two hydrogen gas molecules, each of them having two hydrogens. So 2 times 2 is 4, meaning we have 4 hydrogen molecules now. And 2 times the invisible 1 here, 2 times 1 is 2, so 2 oxygen molecules. So now we have the same number of oxygen molecules on both sides, but we also have only 2 on this side for hydrogen and 4 on this side for hydrogen. So we're going to need another 2 hydrogen atoms. So let's look at this reaction again. Remember earlier we said that this is saying that there's 2 hydrogen molecules bonded to each other. So if we were to write a 2 here, we're saying that there's 2 hydrogen gas molecules and that each of them has 2 hydrogen atoms. So that's 2 times 2, which is 4. It's the same thing we did on this side. So now we have 4 hydrogen atoms. So now if we go ahead and look at this reaction, we see that we have 4 hydrogen atoms on the left side, 4 hydrogen atoms on the right side, 2 on the left side for oxygen, and 2 on the right side for oxygen. So this is now balanced. So let's rewrite this without this 1, since this isn't something you'd ever actually write once you balance a chemical reaction. So we're saying 2 hydrogen gas molecules plus 1, because there's no number here, oxygen molecule, forms 2 water molecules. So let's go ahead and do the same exact reaction, but we're going to draw it a different way, just that way we can be sure that we understand the concept. So instead of using these symbols H and O, let's go ahead and draw them out. So here on the left side, we have a hydrogen atom bonded to another hydrogen atom. This is our H2, and we're adding this to our O2, oxygen, which is an oxygen atom bonded to another oxygen atom. And this is reacting to form water, which is a hydrogen bonded to an oxygen, which is bonded to another hydrogen. So this is our water molecule. Now, if we look on the left-hand side and we count the H's that we see, there's 2 here. And on the right side, same thing. There's 2 of them. But when we look at the O2, we see that there's 2 oxygens and in the water, there's only one. So since this molecule we're not going to break, this is what we're making, we're going to have to draw one more of them. And that's that way we can get that other oxygen in here. So H bonded to an O, bonded to another H. And now we have our two oxygens. But when we look, we also have two more hydrogens, so we have to make them on this side as well. And that means that we're going to have to draw another one of these. So now we have two hydrogen gas molecules, which we can see up here as well. One oxygen gas molecule, which we see here, and two water molecules, seen here and here. So this is a balanced equation. And whenever we're doing these sorts of things, it's really helpful to write out on the bottom of your reaction, at least while you're getting started. So that way you can kind of keep track of everything. Once you get more advanced, you can generally cut out different steps and you'll be more efficient at it. But when you're just starting, it's really useful to stick to the basics. So let's do one more reaction. Do methane, which is CH4, and we're going to react this with oxygen. And this is going to form carbon dioxide and water. So this reaction right here is called the combustion reaction. And that's when you have an organic molecule, which is something that has a carbon in it, reacting with oxygen to form carbon dioxide and water. This is always called a combustion reaction. So let's go ahead and get started. Let's look at the left-hand side. Here we have a carbon, so we'll write that down. We have one carbon, and we have 4 hydrogens, so we'll write that down here as well. And then, same thing as over here, we have 2 oxygens, so we'll write that down here. On the right-hand side, we also have 1 carbon. We have 2 oxygens here, and we also have another oxygen over here. So that's 2 plus 1, which is 3 oxygens. And we have the H2, which is 2 hydrogens. So I'll write that down. So let's look and see which things are not the same. So right off the bat, we have our hydrogens on the left side. We have twice as many on the left side as we do on the right side. So we're going to have to do something to fix these hydrogens. And on the left side, we have 1 less oxygen than we do on the right side. So we're also going to have to fix that. So let's go ahead and look at this water molecule. It has 1 oxygen and 2 hydrogens. So we're going to have to draw another one of these. So we'll write a 2 here. So that way we can get the extra 2 hydrogens. So we'll cross this out and write a 4. And now, on the oxygens, we just added another one, right? Because we have a second water molecule. So we'll go ahead and cross this out and also write a 4, because we've added 1 more to our previous total. So now let's look at the left side and see what's different. So now we have the same number of hydrogens, so we don't have to worry about this molecule anymore, because our carbon and our hydrogen are perfectly balanced, and this molecule only has carbon and hydrogen. So the only other molecule we should need to manipulate for now is the oxygen. And it shows here, since we have 4 on the right side and 2 on the left side, that we're going to need 2 more oxygens on the left side, so that way we can equal that 4. So we're going to go ahead and draw another oxygen molecule as well. And that brings us to 4. So now we have 1 carbon on each side, 4 hydrogens on each side, and 4 oxygens on each side. So this is now balanced. So our final reaction should be 1 methane plus 2 oxygen forms 1 carbon dioxide and 2 water molecules. And that's how you balance chemical reactions. So there's a little bit of vocabulary I would like to go over just before ending this video. So I mentioned a few things here. I mentioned that we have molecules. I mentioned atoms. And I also mentioned elements. There's another word that I haven't quite used yet that I would like to bring up, and that is moles. So moles is a little bit of a complicated concept, so there will be a video just for moles that will explain it in more detail. But in general, you can think of moles like the measurements you would use when you're baking. Say 1 cup, or if you're in Europe, you would say a liter of a certain amount of liquid. And that's what moles is saying. It's just a unit. So we're saying in a reaction here, we're saying we have 2 moles of hydrogen with 1 mole of oxygen, and which forms 2 moles of water. So that's what our moles is. Now our molecules. Our molecules are anything that's comprised of 1 or more atoms. So this water right here, this is a molecule because it has a hydrogen atom and an oxygen atom bonded together. And here we have a hydrogen atom bonded to another hydrogen atom. This is also a molecule. Now when we're talking about elements, this is anything you'd find on the periodic table. So if we just had an oxygen by itself, this would be a single atom of oxygen, and this oxygen is an element. So we'll go into more detail with these vocabulary words here in future videos. And particularly, I think this is probably the most important one since you're going to use this extensively in chemistry. So if you'd like to do more research on your own before I begin the next video, I highly advise that you do. That'll be it for this video. Feel free to tune in next time. And if you have any questions, we also have a Discord which you can join. I'll leave the link in the description. Have a good day.